This week we're going to tackle subroutines. Now, before we start on subroutines, I would recommend going over what the program counter does if you have any uncertainty about that, because that's going to be quite important to this topic. I'll try and go over it as we go through this, but it would be good for you to have a strong idea in your mind of what the program counter is, what it does, and how it works. With that said, let's get started. So what is a subroutine? A subroutine, by definition, is a sequence of program instructions that performs a specific task packaged as a unit. So these are also known as functions, methods in Java, subprograms, procedures, routines, whatever they are. They are just little bits of code that perform a specific task that can be called. And they're also reusable, that's why we care about them. For example, we've done a lot of work with strings, and quite often we've counted the length of a string. Now that would be a good thing to make a subroutine, because you don't want to always just have to write code to find the length of a string. You might want to have that somewhere else where you can call it. But these are a feature of high-level languages, and they're a bread and butter in high-level languages, as you'll all know from writing Java. First things first, you write your classes, write your methods, and that's how you start programming with Java. And these are translated to machine code via conventions, and we'll go over some of them. And these allow different subroutines to work together. For example, this int sum squares, it's just a function which returns the sum of squares for a given number n. This is what a subroutine. It's written in a high-level language here, but we'll be able to translate this down to low-level language by the end of this. So, when you call a subroutine, a certain number of steps must happen. So, the caller must make the arguments accessible to the called subroutine. So, like when you call a function, you have to give it an argument if it needs one. If it doesn't need one, that's fine, but you need to make that accessible to the subroutine you're calling. You then need to transfer control to the called subroutine so that it can do its thing. When you've transferred the control, the callee, that is the subroutine you're calling, has to perform the desired task. It needs to make the return value accessible to the calling routine, so it has to give back what it's made, and then it has to return control to the calling routine. So you'll generally think of yourself as the caller in this scenario. You're the one that has to make the arguments accessible. You have to also transfer control to the subroutine. I mean, likely you'll also be the callee because you'll write subroutines, but the callee is the subroutine you call. It performs a task, makes return values accessible, and then returns control. So we use conventions to make this happen because we have a bunch of registers. Now, we've not tackled the meaning of a lot of these registers, we've just used the ones that we want to, but now they have a meaning, and now the meaning of these registers must be respected. So for the caller, we use the convention that arguments are placed in A0, A1, A2, and A3. Now, I mentioned that earlier, but before we had the notion of a subroutine, it didn't really mean that much. So now it does mean something concrete, and this is what you have to do. 2. Control is transferred using the jump and link label. Now, I mentioned that in the previous introduction to subroutines video, which if you've watched that, you'll have seen this in action. What this does is it stores the program counter in a register and then gives control to the called subroutine. On the other side, the callee must place return values in v0 and v1. So we've used them for system calls mainly, but this is the convention for Mips. When calling subroutines, it puts its return value in v0 and v1. Also, the callee has to return control using jump register. Now, jump register, again, I introduced it in the introduction to subroutines video last week, but what this does is it sets the program counter to be equal to a value in a given register. Now, jump and link will store the program counter in the register RA for return address, and jump register will jump to that address. So here you can see we've got two examples. On the left side, we want to call some squares. So over here we want to call the sum of squares and the value of 5. So what we do is we load the immediate value into A0 because A0 is an argument of 5, and that gives us the parameter we're looking for, and we jump and link to some squares. So this will set the program counter to be equal to whatever is about to happen after this jump and link. So it'll set the program counter in RA to be the next step. Then we give control over to some squares, so we enter up here the label some squares, and we execute this code. you'll note that it's storing the sum here with this add instruction in v0. Now that's because we used return values in v0, that's our convention. And then at the end here, we jump to register, so we jump to the return address down to the bottom here, and that'll take us to whatever the instruction is after jump and link. Okay, so let's have a look at these instructions in a bit more detail. So the jump and link to the subroutine says the return address is equal to the program counter as it is plus 4. So you could think of this as being the instruction or the address of the instruction immediately after the jump and link. And that's so that when you leave to go and execute the subroutine, you come back and execute the next instructions. This is very important for maintaining the integrity of your code, that you understand this instruction. So it stores the return address, the address of the next instruction, in the register RA. That's another register that we haven't used much, but that's what it's for. It's used as a return address for subroutines. And once you've executed this and the program counter has been stored, you then go to the subroutine. So similar to over here, down here at the bottom again, we have the load immediate into sum squares and jump and link. Use the return address is where you latch back onto with your code. So jump register, yep, it's jumping to RA. It's the equivalent for the subroutine as jump and link. So where a jump and link is us giving control to the subroutine, jump register is the subroutine giving control back to us. So this is what allows our functions to jump over to a bunch of instructions in low-level code, execute them, and then jump back to where we were previously. So that's everything I wanted to go over in this video. These things will become a bit clearer in practice. I'll be uploading some example videos of how we use these when writing subroutines this week, and hopefully they'll help illuminate anything that wasn't quite clear today. But really, I just want you to understand the conventions of calling and what must happen every time we have a subroutine call. So that's everything for today. I hope you found this useful. If you have any questions, please do let me know. Thanks.